So hello everyone, welcome to my YouTube channel. In this video, we are going to learn how we can model a beam element in ABAQUS software. First step, like we have to set our directory because normally when we are working, we forget to set our work directory. And for example, right now I forgot to work. I forgot to save my work directory, and when I come back after 1 hour, I was not able to find where is my system, where is my correct that model. Normally, by default, if you forgot, this will go to temp file. If you forgot to set your work directory, then it will go to temp file. So first we have to set our work directory. So I will set my work directory here. I will write. I will go to here, and then I will save like class abacus. This is my work directory now. So my module is saved, and we can check whatever we are doing here. We can check here like application restart, like something. When I will tell you what we can check from this command window. So first step, we have to save our work directly. Then, like as I told you, we are having different module like part module, property, assembly, step, interaction, load, measuring, all step by step we have to do so that it is like let chance of error very less. So first I'm going to take simple cantilever beam. So first I will write some properties here. For example, this is our cantilever beam, and we are applying one load here. Sir, can you hear me? Okay. So this is cantilever. Yeah, this is point load, and it is having some dimension. Like for example, this is circular. It is having dia around zero point 0.5 meter, and a load P equal to around 100 kilonewton, and this is steel. Okay, so E we will define, and other end it is this one is fixed. So this is our fixed end. So this one we are going to simulate in ABAQUS software, and we will check what we are going to get. For example, I am putting point load at this location, and I want to find displacement at 3 end. Okay, okay. Hello, sir. Okay. Can I continue, sir? Okay. Okay. So, I'm applying some load P. So I will just write here. This is load P. This is load P, and I'm going to apply the free end, and I want to find displacement at this end. So displacement at free end. This one. Sorry, sir. Yes, sir. And this is solid. This is yeah. This is solid state bar. I will just write solid, or like we can take solid. Normally I'm taking hollow. So we can take whatever we want. So normally we are taking hollow bar, and okay. So this is our system properties, and I want to find displacement this screen. This is fixed end. So I will just write here. So this is fixed. Okay. So first I will do model analysis, like how we are going to find natural frequency mode shape. Then we are going to do that static analysis for how to find displacement this end. Okay, sir. Okay, so now okay, I just forget one thing. We have to write length. So I will take around 10 meter. This is length. L equal to 10 meter. This is length of this bar. Okay. So now this is our Abaqus interface. So how we are going to draw this? How we are going to get displacement and how we are going to get natural frequency mode say for this cantilever beam. So this we are in like we are having different module like. So first, if we are doing CAD in Abacus itself, so we have to design our model. So I will create that part. So this is when I click like this one, create part. Then I will write like for example beam. I wrote a beam cantilever beam. So we can write any name cantilever canti beam. This is about 2D, so we are going to write 2D planar. We are going to select, and I'm taking. So we can take cell, wire, point. So I'm taking wire. Okay. What is this? Is this is like approximate size of this interface. So normally we are taking 200 because our length is 10 meter. So 200 enough like big. So we don't need to change. I will just click continue. So this is our designing the interface. So so we are having different CAD commands. So like for point, for circle, for rectangle. These are the different CAD command, and for according to our according to our model, we can select whatever we want. So like for example, I'm taking simple beam element. So I will select line, and this is origin. So I will just click one and uh, I will click second. So like second end point, and you can define dimension. So just you will click escape. Then I will go to this is our add dimension. So I will click add dimension. I will just double click and our new dimension will come here. So initially it was like 25 meter. This is was random. That but our dimension 10 meter. So I will give 10 meter. Okay. So this is 10 meter and dimension done. And I will just click done. So this is our 10 meter wire. One more thing I want to highlight here in Abacus, dimension we have to remember because we cannot change our dimension. Like for example, unit like to meter, meter to centimeter, or meter to feet. So whenever we starting our simulation, we have to remember dimension. Like for example, I am taking Newton meter or kg meter, whatever suitable for us. So normally I'm taking Newton meter and second, like simple SI unit. Okay, sir, this one we have to remember for dimension. So like I define this simple bar element. Now we have to move to these are the different command for different like for solid and like cell. So we will go in coming time, but initially we are taking bar element. So after designing parts, so second step we have to save our model. So like this is for just below the model we have to save our model. So I will say save, and this will go to our directive, whatever directive we define. This is our class Abacus directly. Then I will write here model uh, model canti beam, and I will just click OK. And this one we can see here the model database has been saved to this is my directory, my drive class 8 July. This is my directory. So this one we have to remember because if I forget to save model, maybe whatever work we are doing, it will go disappear. So we have to take in mind that model we have to save after doing every like one two module. So I can check. I will go here and we can check this is our. I will save model cantivim. So when we are saving our model, it will generate two type file. First one CAE file and second general file, JNL file. This is called general file. So this is this is generated by default because due to that Abacus. This is CAE file. CAE file store our all information. So any doubt till now, sir? Okay. Okay. Now, after, so we will go to property. Then we are going to define our material property. So I will write here this material name is steel. Okay. Then density. So we are taking steel. So 7850. Okay. Then elasticity. So we are taking 210. 210 mega that gigapascal. So 210, and we can write 0.9. Then Poisson ratio zero point 0.3. This is our property, our steel property done. Now we are going to define that diameter. So we have to go create profile, create profile. So we are taking like pipe circular. So I'm going to take pipe. So this is like I will take profile beam. Then I will click here. We can take any arbitrary. So we can take whatever even like rectangle, hexagon, trapezoid, circular. So I'm taking pipe, profile beam, pipe. Then continue. Then it will come like this. So we have to define radius and thickness. So this is outer radius. So our outer radius, like I taken zero point 0.5 diameter. So this will become zero point 0.5, sorry, zero point 0.5 by 2. Or it will, I will write here 0.25. And thickness, like we can take around 10 thickness. So like 0, yeah, this is meter. Oh, sorry, sorry. This is 2 pi. Correct, sorry. And we are going to take like 10 centimeter thickness, that thickness, so like zero point 0.1 thickness. Or we can take 10 This is fine. Okay. So radius thickness, that we have to click OK. Okay. So we define our, we can check like from here, we can check like for this is our, sorry, I will. This is our steel property. If for example I want to edit, so we can edit from here, and by clicking near to that create profile, we can check our beam profile. Yeah, we can check. So now after defining beam profile, we have to assign. We have to create section. So I will create. I will click create section. This is our beam. So I will write create section beam. Then continue. Then we have to select our profile. So by default, we are having like only one profile. So by default, it will come profile name, whatever I saved profile beam. And we can define again Poisson ratio zero point 0.3 here if you want. Then, okay. From here also we can define like second profile, but we are having only one profile. So we don't have to define again. Okay, I will cancel here. Then, okay. So till now we define that create profile and section. Now we have to assign this one. So I will click here, assign section. Then we are not going to create any set. We can create also, but I don't normally. I did not prefer to create set. So then I will select this whole structure. Then I will click done, and it will come section. We are going to define section beam and click OK. So after defining assigning section, our color will change, like it will come like some greenish. Initially it was something else. So for example, I will remove this assign. See this that color was white, but after assigning it will become green. So we can see our that uh, section of beam is already assigned now. Yeah. Yeah, yes. So this is like green. It is like for unassigned section it will be white. For assigned section it will become green. Okay. Yeah, green for this assigning. Now, after assigning section, that we have to assign orientation. So just we have to click here, assign orientation, and we have to again select this whole profile. Then done, then enter. So like this, like this is 1 and 2. Okay, then yes, yeah, this is, Okay. Okay. So, sir, like for that one, I will make some like two frame element, like a two story element, two story that frame. I will tell you how we are going to assign. Like just be, for example, just wait. I will do here itself. For example, in part module, I will design other like I will write like frame two story. Then continue. I will just draw one frame here. Like this. Then I will add one more element here just to make little more complex. Okay, done. That dimension I will take this one. This is like around 15 meter. Or I will keep 15, and this one 15. I will take this one around 5 meter. Okay, then done. So this is our two-story beam element that frame. For example, I want to give dimension different for different element. So let's we will go to our property. So simply we are having that steel material property. Then for example, I what I want to do for vertical member, I want to keep diameter 0.5 meter, and for horizontal member, I want to keep diameter 0.1 meter. How we can give? So for example, right now we are having this dimension, so this is for vertical member. So what I will do, I will assign like here create section or like assign. I will select this one, this member only. For one member only we can select. So did you got my idea? So for example, this member I'm going to select and I'm going to assign. So this color will change for this member. See this will become green. And for example, for horizontal member, I want to give around zero point 0.1 meter. So again, I will go here. I will create new profile. So profile number 2, and I will uh, thickness I will keep same, and this dimension will become 0.05 meter. And yes, then done. Okay. So I'm going to assign section member 2. Continue. And see, now we are having option which profile you are going to choose, like profile 2 or profile 1. So I'm going to select profile 2. Then I'm going to assign this one. So I'm going to select this horizontal member and done. And I'm going to select section 2. See, this color also got changed. And if you want to see exactly which different member, so I will go here, property, and you can select section. See, this is having different color, this is having different color. Did you got my idea, sir? Okay, okay. So I will just remove this one. I will just delete this two-story frame as of now. Then we will go over with our cantilever beam only. So we can just we can delete from here, and then okay, then this one. Okay. So till now we have assigned this our property for this member. Now we are going to move for into next module, assembly module. For example, I am having different part in assembly module. we can assemble and we can make one member, like one structure. So what we have to do? We have to go to assembly member, then we have to click create instant, create. Then we are having different that dependent independent meshing part. So just normally we are selecting independent, then okay. So this is our that our member will come here. So we can move our member anywhere, whichever location we want. So these that command. For example, I want to see in 3D view, so you can select like 3D, YZ, XZ, XY. So any view we can see by using these command. So now this assembly we are having only one member, so we have to just only create a stand. 1 minute. अरे सही था हल्ला नहीं करो. Okay, and then what happened? Okay, so assembly module. Now हल्ला नहीं करो. Now we are going to move step. This is one of the most important command in simulation, because we are going to define different solver here. So in step module, what we have to do, we have to create a step, like create a step. Then I will write like simply that step, or like for example, first I am going to calculate natural frequency. So I will write natural frequency. Then to find natural frequency, we have to go general here. Then we have to do linear perturbation. Then we have to select frequency and continue. So here we can select different solver. So normally we are selecting length code solver. Subspace also you can do, but normally we are following this one, length code solver. Then how many that mode shape you want? For example, I need 5 mode shape or 5 natural frequency. You can get all whatever we want, but normally till 5 our that task can be normally has been done. So we are selecting 5. Then okay. We are keeping everything like by default. We don't want to change anything here. Then okay. So we can check. We have defined step. So this is our step, natural step, and we given value 5 for natural frequency, and we can check whatever we want. Okay. Then we define property assembly step interaction. We don't have any interaction, so we are not doing anything. We are having simple bar. Then we are coming to boundary condition. This is like loading or load module. So we have to define boundary condition. So this is create boundary condition. Then I'm going to create boundary condition. So this left end is fixed. So normally like boundary condition apply on initial step. Normally, generally, or like this is procedure that boundary condition like fix or like any boundary condition we have to apply on initial step. So this is boundary condition, like I will write one and fix end. I will just write, then continue, mechanical continue. Then I'm going to select this end. Okay, then done. Then I'm going to encaster. So because we have to register all horizontal, vertical, everything. So I will just register all encaster. So like this is mean that yes sir. Any doubt? Sorry sir. Hmm. Save. Yeah. So yes. We have to save. Okay, sir. I will just save here. So here, just below the module, we have to save our module. Again, save. So it by default it will become save. So this is good practice that every 10-20 minutes we should save our model, because in between our model maybe something happen for our system, our whole work will go. So we should save in between. So like just below that module we have to click save module, and this will display here. like model database has been saved. This is our work directory. Okay, sir. Okay. Now, see, after applying boundary condition, see, so this is, we can check by clicking here, we can check. We are seeing some some boundary condition like symbol. So it's mean that this end is fixed in caster. All degree of freedom it is having zero displacement. Okay, sir. Now this is boundary condition, but in our problem, okay, this is our fix. But in this free end, we have to apply some load. So this is also one boundary condition. So, but loading we have to apply on this free end. So I will go here. This one, create load. So I will create load. Then, but loading we have to define on. See, we are doing natural. We are doing that what we are calling like frequency analysis. So we don't have to define any loading. Correct? Because we are doing modal analysis. So simply I will cancel here. Then I will go to mesh module. I will create here, create seed, like select. So I am going to select this member. What actually? Why it is not coming? 1 minute, sir. Maybe something happened for my software. This is connected. Maybe I will just save here and I will open again from this position. Mesh. Then what? Okay. Okay. So actually the window is not coming. I don't know what happened. It is going beyond that window. But by clicking, I just click enter. So what we can see here that our that a member is divided in like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In different 11 small element. Uh, can you hear me, sir? Okay. Yeah, like because some actually heavy rain is coming near to my place, so little some background sound it will come. Sorry for that one. Then after assigning seed means like how many element we are going to divide over this whole member. Like I divide in 11 element. Then then we have to generate mesh. So we will click here. Then I want to create yes. See, just then I will click here or what we can do. I will remove this seeding from here. Okay, removed. Then I will assign local seeding. So see, local seeding means, for example, we are having T joint. So at near T joint, I need very fine mesh, and beyond T joint, I need coarse meshing. For that one, we have to assign local seeding for this one, like local seed. So I will select this member, done. Then how many element I want? Like by number, I need 4 element. Number of element, it will divide in 4 elements. So I will just click apply. See, this is in 1, 2, 3, 4. This is having 4 element. For example, I need 10, so I will just I need 10. I will just increase number of element, then it will become 10 element. Did you got idea, sir? Okay. So for example, I'm just taking one element for like simplicity. I will take one element. Apply one element. Done. So seeding done. Now we have to that assign mesh. So I will just click yes. See, color got changed and it is showing one element has been generated. it means that meshing of this element has been done. Okay, after meshing we need to move to job creation. So job module, then I will create job. Then see, I am going to write simply job 1 and natural frequency. One more thing we have to remember here. When, for example, I am writing job name, so we cannot put space like this. We cannot put space. We have to use underscore. That like simple one information. So I will write natural and frequency. Then right now we are having only one module, so I am keeping module number 1. By default, it is coming module number 1. So this left side, it is called module tree. So we can suppress or we can open this one like this. This is called model tree. And I will continue. See, something happened. I did some name. Maybe I kept some space here. So if I kept space here, so that it will display invalid name like this. So we have to remember that I will just remove this. We are having one space, so I will remove this space and it will save. Okay. Then okay. After creating job, we have to submit our job. So submit or before going to submit, this is like good practice. We should check our data. We should do data check. So I will just click data check. If is there any error, it will show some error. If it is everything fine, it will not show any error. So it is checking data. It will display like job input file has been submitted for analysis. It will come like this. It is checking. We can monitor here like some status is running. It is checking data. So it so that uh, processor completed data so everything fine. It is showing that a file processor completed successfully and this is fine. So I think our data is okay. After checking, we can submit and okay. So we are going to submit our analysis and we are going to check natural frequency and mode shape. Sir, are you from civil background or mechanical background? Oh, oh, that's fine. Okay. Oh, that's great. Sir, I'm totally working on steel only right now. My PhD thesis, I'm working on offshore steel structure, jacket structure. Okay. 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 So, sir, this is called job manager, and we can check our file status. Our simulation has been completed, or we can check from here also that whatever file name we saved, like job one, natural frequency, completed successfully. It means that there was not any error. So after this, we can go to we can check our result. So I will go to result. This is result, and what I we can click here plot contour. So I will click here, and then by clicking multiple deform and undeformed shape, so I will we can check here like this. So this is first natural frequency. So this whitish color undeformed shape, and this is like first natural frequency. Then by next we can take second, third, fourth. Total we are having 5 natural frequency. So by result we can check from here we are having, oh, I selected only 3. So this is having 3 natural frequency. Yeah, yeah. Actually, we selected five natural frequency, but we are having only one element. So maximum like one element, each node having 3 degrees of freedom. So maximum it can have three, but we given five. So it will not go beyond three. For example, we want to go beyond C. So what we have to do? We have to increase our mass element. Like for example, I will go here mass, and what I will do, I will just right now be taken one element, be taken only one element. What I will do, I will take like three element. So apply, okay, done, apply, okay, then create. Yes. So see, it is having three element has been generated. So now it will, how many modes it will have, because each node having 3 degrees of freedom, and it is having total three element. How many? It means that four nodes. It will have maximum 12 degrees of freedom. But right now we are extracting five only. So again I will go to job, and I will create second job with like new, then continue, okay. Data check we already done, so directly I will submit here, submit. It is running. We can monitor here status running. This is called like job manager. We can like we can manage our job from here. Okay, completed. I will go to result. We requested five more shapes. See, now it will show five. So like deform, undeform, like how many result step. See, it is having five. One, two, three, four, five. So like this is first mode shape, second, third, fourth, five. It is okay, sir? No. Yeah, because like it should be curve. I got your idea, sir. It should be cut because right now I'm taking very coarse meshing. If I go very fine meshing, it will curve like a curve. So I will just change my meshing here. Then it will curve very like a sine curve. So I will take here around 100 element. Apply. Okay. Um, See, it I taken 100 element. It is displaying 100 element has been generated. Okay, then I will go to again job, create new to, continue, okay. I will submit again here, because when we are taking coarse meshing, so it will look like a rectangular, but when we are taking very fine meshing, it will look like a like connected dots, so it will like a sine curve. In our third job, number third, it will display like a sine. Meanwhile, yeah, so meanwhile we will check here result. So this is called visualization module. Here we can see different like mode shape, deform, undeformed shape. If I want to plot, like I want to get displacement from some location, like for example, okay, this job has been done. So we will check this one. Okay, so job 3 result, then first mode, okay, See, now it is coming very like a clear sign, right? So it depend on like mess. Like if I'm taking coarse mess, maybe someone taking very coarse, maybe someone taking fine. So for that one, we have to do mesh conversation, right, sir? So mesh conversation means like we have to run different analysis by changing mesh size. So like for example, for this problem, I am taking 100. Maybe like mass will converge around 50. So we don't have to go beyond 50. We will keep our 50. We don't have to go to 100 after doing mass conversion. Okay, sir. So any doubts for from this problem? Okay. Now now we are going to move to our this is right now we check like this is our natural frequency analysis. So I will just remove this step. Then I'm going to create. I'm going to put one point load according to our this PPT file, and we are going to observe displacement this free end. So a step like point load and static. So I'm selecting static general, continue. We don't have to change anything because this is very simple beam. So for example, we have a very complex structure, so we have to select number of increments. So for this problem, we don't have to change anything. Just keep OK, done. And we don't have to change anything like property, assembly, everything we will keep fine, same as it is. Only we have to change our point. We have to put our point load at this end. So I will select load. So I will keep point load. Concentrated load I'm going to keep continue, and which end we want I need at this location. So I will select this node, done. And we have to define the intensity. So for example, CF1 means horizontal, CF2 means vertical. So I'm keeping minus 100 kilonewton and okay. So this is 100 kilonewton load downward direction, negative by direction. Okay, everything messing is fine. We don't have to keep or we don't have to change job. Now I'm going to create new job for static static loading, continue. Okay, then I'm going to submit it. It will take some time, maybe few minutes. We can monitor here, status running here. So meanwhile, I will explain one thing here. So see, this is our directory. We save our model as a this model cantilever beam. It generated so many file like .dat file, INP file, text file, ODB file, PRT file, SI. These are the some file extension for Abaqus. So as I told you in this PPT here, I told you we have to consider about three type file like .cae means our module file, .inp means our input file, .odb means our output file, and these are the some message and log file. So we don't have to like worry about these file. It will generate automatically by default by Abaqus. So, okay, it is completed. We can check from monitor window. It is completed. So we can go to result. Okay. So now Okay, from here I will explain it from here. So we can get, like, for example, I need displacement. I need, like, U means displacement, UR3 means rotation. Rotation means rotation about XY plane. Then RF means reaction force. CF means center, like concentrated force. For example, I want to check displacement U in which direction? Vertical direction, like U2, like U1, U2, UR3. So do you have idea what I am saying this U1, U2? Yeah, yes, correct, correct. Yeah, correct. So for example, I want to check displacement at this location. So see, I will go just probe value. I will click here and make it smaller. So I will select from here node and see. I will just click. This is node ID means 101 means this is 101 means this is node ID of this element, or like this node 101. And this is, yes sir, which node? Yes. So like when gate लगा लीजिए when. So this is displacement, our, like this is our result, vertical displacement. This is our minus 0.34 meter in vertical direction. For example, I want to find displacement in horizontal direction. What I will do? Simply I will go here, probe, and before going to click node, I will click here U1 in vertical direction, and I will click at node, this node 101. So it will come minus 0.25, sorry, minus 2.53. This is vertical displacement because we are putting point load, so vertical displacement is near to 0, 10 power minus 19. Yeah, horizontal, yeah, sorry, yeah, horizontal displacement. It will be near to 0 only. And because of vertical load, what is the rotation at this node? So we will just select here UR3, UR3, then I will click here. So this is our rotation at this node because of vertical loading. This is minus 0.53 radian. This is not in that degree. This is in radian. Okay, sir. Yeah, this is toss. Yeah, correct, correct. This is torsional twist. Correct, sir. For example, as I told you, our this end is fixed. This end is fixed. So I will check displacement. By default, it should be 0 because according to that our knowledge. So what I will do, I will just select displacement here, probe, and I will select this node. So this is node ID 2, and this is node ID. I will select U2, U2. It should be 0, I think. Yeah. This is minus 6.65, 10 power 5. This is 0 only, near to 0. Correct, sir? I uh, maybe I let me 1 minute. I will pick correct node, so it should be 0. What I will do, I will write, I will write here node. I will write here node ID 1 and enter. So see, this is coming minus 1 point. Sorry, minus 1.. minus 1, 10 power minus 31. So this is like 0 only, node ID 1. So we can select from that structure also, or if you know that node ID, simply we can go k level and we can write our node ID. For example, I will write here node ID 50. It will go displacement. So 50 ID means this is near in between, like this is in middle of this our member. This one. For example, I will write here 1 node 1. So this is free end. So this is a 1 node 1. And for example, I want to write 2. So this is 2. Did you got idea, sir? Okay. So this is for this simple beam element. And I will save our okay. Okay. So now I will move to that our T joint, that little bit complex. Okay, sir. So this is our part. What I will do, I will make one more model. This I will close and I will go again CMD. Abaqus CAE. So we have to select standard. Now again same step, we have to select our work directory. So work directory what we are having, this is our work directory. Here I will add one more folder, T joint. I will write T joint. So this is our work directory. I will select copy, then set work directory. Okay. Now what we are going to do, we are going to make one T joint with cell element. So I will create, I will just demonstrate here what we are going to do in this second problem. What I will do,